Hey YouTube, so back here again, hoping to do a short video on how to actually make a heated steering wheel, kind of as a follow-up to my older Forester heated steering wheel video. So right now I'm in a Subaru Legacy 2008 and looking to accomplish much of the same thing. Basically get a heating element around the wheel rim, cover it up with a steering wheel leather wrap, and then wire in through the clock spring to get that heating element working. So just going to be kind of a montage of the different steps involved and some of the key points. Hope you'll join me, and yeah, let's go. Let's do this. Step 1, remove the airbag. It's got two connectors. It was held on by two fasteners in this Subaru. A lot of cars will have different systems like spring clips and whatnot. Anyway, get this out of the way, and you have access to the nut that holds the steering wheel on, as well as the wires from the clock spring. So this can, your different buttons on the steering wheel will connect to these wires, and hopefully there are some that are unused, let's say for paddle shifters or something else, that we can actually use to run the voltage for the heated steering wheel element. Be sure to mark the alignment of the steering column and the steering wheel so that when you put it back on, you get it on perfectly straight. You don't have to realign stuff. Once you get the nut off, there's going to be a lot of force holding the steering wheel on, so you'll need to pull on it from the top and bottom and whatnot. But once it's ready to come off, you can remove it, make sure the wire is all clear. In this case, it's like this. So you can finally set the steering wheel aside so you can work on it. And here we see the clock spring. So this is the rotary electrical connector that allows your horn and airbags and everything to work even as you twist the wheel over and over. So inside here there's a flat ribbon cable, quite a long one that spirals around, and it kind of allows this motion without interrupting the circuits that exist there. So this is what we'll be passing high voltage through and very low current, because the ribbon itself is very thin. High current will just burn it out, and you could potentially damage, safety systems like the airbag. All right, now that we have the wheel out of the car, we can start to actually route the heating element, the Nichrome wire. So right here, I'm using 36 gauge wire. It has a certain fairly high resistance per unit distance. But you'll want to use a multimeter specifically to measure the resistance of the circuit that you're making. What I'm going to shoot for is around 700 ohms of resistance. That's probably, 10 feet of this wire. And then powering it with the equivalent of like 80 volts of voltage coming from an AC transformer. So yeah, next step, I'll just start routing this wire along the wheel and focusing most of it along where you rest your hands. So I've just started routing the wire here. I've secured it on the front of the wheel, and I've got the loose end going in behind the airbag. The reason I chose the front is because I know that the steering wheel wrap that I got definitely covers up the front of this bottom spoke, and I'm not exactly sure how much of the rear it covers up. My Forester, I did route it through the rear, but you need to make sure to insulate whatever wires are here, because if you touch and connect the circuit here, you'll be experiencing the peak voltage that this circuit has to offer. So yeah, as I'm going, I am trying to do a little bit of a weave here, because I want the wheel to heat a little bit more than if it were just a straight thin wire. But really what I'm trying to do is get over to where this right spoke is, and with that spoke is where I'm really going to start a zigzag, much more dense, so that it can heat up that area a lot more significantly. Alright, so a quick update. So I've been routing this wire all the way up through the right spoke of the wheel, and once I got to the 3 o'clock position, had a whole bunch of loops to try to maximize the amount of heat going to this area specifically. And then I'll be continuing on through, loosening up the curves right around here, and then restarting with really frequent coils here, and then end pretty much right where we started. so that we can feed the wires from the clock spring straight to these two leads. Now what I want to do here, since I'm not working with my final length of wire, is I want to use the multimeter to measure how much resistance I've currently taped onto the wheel. So let me just see what I can accomplish with one hand. So one lead here, the multimeter set to measure resistance. That's enough. And then one lead over on the other side. And I'm just gonna read it while holding it. And it looks like the current resistance is about 130 ohms. So that's probably less than a quarter of what I'm aiming for. So that tells me I should either unwind this and coil it tighter, or do more coils up through here or something like that, just depending on where you want the heat to go, so that I can use up all like 700 or so that I'm aiming to use all the way around. Alright, so once I got past the spoke area, I decided to just wrap it around the wheel in a spiral, which was a whole lot faster and easier. And I got to the halfway point, and it's looking like right around 350 ohms, which is about what I'm aiming for. So if I can repeat roughly this density of wire on the other side, I should have an even, 680 to 700 ohms, which is what I want. So we'll update again once that is done. Alright, so finished up wrapping all of the right side and all of the left side of the wheel, and finished both loose wires coming up right here up the bottom spoke. Measured the total resistance across the two wires, and it's just over 700 ohms, so in the ballpark of what I wanted. And actually hooked it up to the transformer that roughly converts 12 volts DC into 220 volt AC, so roughly 240 volt AC. The way it does this is in a more digital way. It's like square waves up and square waves down. I measured the voltage output, and it's about 80 volts RMS, which, if you wanted to equate the AC output into a DC output for easier calculations, that's what you'd be working with, about 80 volts. But yeah, now we're actually ready to test power this up. So right now I've got it hooked up to the maximum 220 volt output of this little transformer. I've got it hooked up to a DC power supply. So when we turn on the supply, we've got this sending out 12 volts, and we've got that getting bumped up to 220 volts, getting sent through these two thin little wires out to the wheel. So as a baseline, we can measure the temp of the wheel right here. It's like about 80 degrees, the desk is 78 degrees, and as it heats up, we are going to see all of these parts warm. Look at that, 100 degrees. And over here, over 100 degrees right away, so we gain 20. And as we sweep, we'll also see where, I guess, the warmer and cooler spots are. If I had an FLIR flare camera, it'd be a lot cooler, but yeah, as you can see, there's quite a warm spot right here somewhere. It's already at 130, about where the thumb will go, I guess, when holding the wheel. And as we go down, there's fluctuations. But yeah, this test is really meant to make sure that we wired it up correctly and that it actually does warm up as much as we hope. The link will be posted for this transformer, so if you want to just use my math, 36 gauge Nichrome wire, about 700 ohms of it, connected to the 220 output of this. This gets uncomfortably hot pretty quick, which is real nice for a cold start in the winter. Alright, next step is to actually put the steering cover on. So rather than spend more time with the wiring, which I'm pretty happy with, I'm going to go ahead and cover this all up. The instructions that come with these kits are amazing, and if you're ever doing just a regular steering cover, by all means follow them word for word, but they come with this double-sided adhesive tape, and it helps keep all the little flaps and stuff in position, both while you're sewing and afterwards. I'm going to say skip those if you're doing a heated steering wheel, because whereas this thermal tape is not going to do anything when heated up. The basic double-sided tape here is going to stink up your whole car for a few weeks. That's something I learned from experience. So basically, I'm gonna just try my luck just stitching it on, and yes, it might like wiggle slightly when it's finished, but that's okay with me. Might decide to put a little bit of tape on where there's no heating elements, like around here maybe, but for the most part, gonna avoid it. Alright, so I'm beginning to make some progress on stitching this wheel cover, and I've hit a bit of a snag. No matter how tight I try to cinch the two sides, I can't quite close the gap entirely. And the reason you can see this tape through it is because I specifically wanted to prevent it from poking through at all. And it's also keeping the wire in place. So I think what I'm going to have to do, and I'm assuming it'll apply here as well, I'm just going to put some black electrical tape on top of this thermal tape. And I think this will risk the electrical tape causing a smell, but it'll also help speed this along. I won't need to fully close this gap, it'll still look pretty good, red on black. So, alright, so here I've added electrical tape to cover up the thermal tape all around the rim, and including in this section, which I have now finished stitching. So, third of the way done. Stitching up the top of the wheel right now. Stitching complete. Unfortunately, the cover was quite a bit too small, but with the electrical tape, made the best of it. Alright, now that the steering wheel is complete with the wiring and everything, the next couple steps are to figure out the lead from the two exposed Nichrome wires that the steering wheel ends with, that will go into the clock spring. So in this case, the cruise controls that are on my steering wheel all plug into this connector, and then this controls the horn and the airbag. There's this completely empty separate connector that I plan to use. So I've plugged in 6 different wires, the idea being the more wires going through the clock spring, the lower the current that needs to go through there, because it'll effectively reduce the resistance and the voltage drop that the clock spring experiences, so less heat and less wear on the clock spring. To get the other side of these connectors to figure out where to plug stuff in, I've lowered the bottom of the steering column cover. And at this point, it's just going to be a matter of tracing, you know, this is all clock spring right here, this plastic bit. And it has 2 wires coming out this way and another wire coming out this way. So I'm going to figure out where these end up and then how to plug in and trace these 6 wires that I've installed. Alright, so I finally found the output of this roll connector. So again, the roll connector is this whole thing. It's got this black plastic piece that doesn't roll, and it's got this one that rotates with the steering wheel. It has a bunch of wires that lead out of here, and they go around. This is the airbag wire, and one of these is probably the horn wire. One has a harness of multiple things. I found that it actually leads to where this plugs in, right up in here, all the way in here. There it is. And in here there's a set number of pins, 14 of them. And my task was to figure out, of the 6 that I plugged into the steering wheel, which ones have connectivity through a multimeter. So I'll basically try each pin and see which one is connected. So was able to compare the diagram that Subaru has, figure out you know, which of those unused signals actually goes through here. So I think what I ended up with was stuff like the multimedia buttons. Some models have a button for like the sport sharp driving mode, stuff like that. So finally identified all 6 of these wires, and what I'm going to do is basically just twist together the 2 pairs of 3 wires and pass, you know, essentially the positive and the negative, if you will, of the 220 volts AC signal. And what this will help do is distribute and lower the resistance and the load that's going through this roll connector, because effectively, hopefully, tripling the current capacity of this. Not that it's necessary, it's just a small like safety measure. Give you a little bit more headroom as far as like sending more power through this roll connector, because worst case scenario, this thing heats up, wire melts, and you know, you got to replace like a $50 to $100 part right here. So yeah, so now that that's done, what I'm going to do is, this is the harness that plugs into it, and I basically know that those 6 wires are completely unused. So I'm just going to cut them all, and I'm going to twist them together just like I've done here, and start to send the actual signal from the transformer into the steering wheel. Alright, so now that we've figured out the wiring through the clock spring, I've actually placed the transformer into a box. It's actually kind of hard to see, but I threw it into an old like oil filter box, and I installed it, kind of wedged it back here where there's just some empty space behind the dash. And out of that box we've got the wires, the output from the transformer, so we just need the 2 wires going to the steering wheel. And I've also plugged in a switch here which controls the connection from the 175 volt kind of positive output to the red steering wheel wire, and then the 220 volt positive, we'll call it, output to the steering wheel wire. And then the ground will be uninterrupted from the transformer all the way up to the steering wheel, this black wire. So yeah, I've already pressed the switch in, so it's hard to see any of the wiring there, but yeah, essentially just running this through. Also, I went to the extra length of twisting this wire with a drill. I just did it for fun. I don't think there's any need for you know, worrying about interference or shielding or anything like that with the signal. So, but anyway, it keeps it all together. The next 2 things that I need to do would be simply connect the wires here to the inputs to the clock spring, which I've already twisted up, the stranded copper wire right there. That's pretty easy. The harder thing is finding a fuse to connect the input to the transformer with. I'm looking around and I don't have the tap-a-fuse things handy, so if I wanted to use an actual fuse that's in here somewhere, I'd probably have to like crack it open and solder the connection to it, which is I think what I did in the Forester. The other thing that's looking really appealing is right here, there's the main ignition switch. When you turn the key, accessory power, you know, one of these thick wires gets power. You know, I could just splice into this. I would just need to run an inline fuse to protect the circuit. So, yeah, so that's the next thing to figure out. Alright, so I've decided what to do with the power for the transformer. I'm gonna take it from an unused fuse rather than cutting into these mains. Mostly I'm nervous about this because once cut, I would need to crimp these wires back together, and there's just a huge gauge wire. It's probably got some like pretty thick strands inside, which I don't think I have like a crimp big enough for, you know, essentially 2 of these plus you know, this wire or, you know, an inline fuse. So gonna go with the tried and true tapping into a fuse approach, and I've decided to solder on a barrel connector onto a 15 amp fuse, and I will install this monstrosity into an unused fuse, specifically the rear washer and wiper fuse, so the center of the second to last row. My car is a sedan without a rear wiper, and this fuse switches on with accessory power, so should work great. Alright, buttoned up the bottom of the dash. Through here you can see the fuse that we're tapping. That's going off to that box that contains the transformer. We installed the switch with the low, off, and high modes. And we've got our clock spring with the wires ready to be connected to the steering wheel. So it's finally time to put the steering wheel on. I'm going to pause the camera, put it on, resume. The important thing here is to take care to align the marks that we made with white paint, basically to make sure that the steering wheel will be straight when the car is driving forward straight. Alright, so the wheel is on, the marks are aligned. It is how I remember it sitting, so perfectly straight when moved a little bit to the left. I did miscalculate the length of the wires coming from the clock spring to the bottom of the wheel. Turns out they needed to be a bit longer, so spliced in these two extensions. Not too worried about their size, since at this point it's all the high voltage, low current stuff. Yeah, so plugging stuff back in. The airbag is all plugged in, so should be ready to reinstall. And hopefully it's got enough room, clearing the new wires leading to stuff. Alright, it's on there. So I'm going to use a Torx bit to actually secure the wheel. Oh, actually, I'm an idiot. Need to put the nut on. There it is. And yep, I'm just going to spin that on and figure out the torque spec, since you don't want this coming off. Alright, so I've just reconnected the battery. Moment of truth. We're going to turn it into accessory power. And we are going to see if this works. No airbag detonation. It's always good. Alright, taking a video of the steering wheel function with the car on. So I realized that in my very first test, it was just battery power and it was a little bit slow to heat, and also I didn't want to drain the battery with the engine off. So I've got the car running. Let's get a baseline temperature for this thing. 78, 77, 75. Now let's turn on the steering wheel heat. So right away we see a jump to 79 in one spot, oh, all the way up to 80. $85, 86, 90 right here. Yeah, you can definitely feel it getting through the cover, which is nice. Yeah, pretty cool. So not like super aggressive. If you wanted to like really maximize the heat potential, what you could do is have like a short segment that's extremely tightly wound, and then just do like no winding, just a straight wire all the way through to the next segment that you really want to heat up a lot. That's more similar to what I did with the Forester. With this one I kind of zigzagged it all the way through.
That's her turn.
And yeah, so as a result, the entire wheel rim will heat a little bit, with a lot more heat in the sections with more density. But yeah, I'm already feeling it. So, and I expect it'll just keep getting hotter and hotter. And that's, I guess, one nice thing about the circuit. But by this design, there's no built-in, like, I guess, thermostat or safety measure. So it's all on you just to feel when it's too hot to hold, and then you just switch it off or switch it to low. Low being the 175 volts output. Yeah, so hope y'all enjoyed watching this. I enjoyed making it. You know, having done the Forester already, this took a lot less time for me, especially since it's on another Subaru. But yeah, if you have any questions, please comment below. I'll try to leave links in the description for all the things I used. It's absolutely the same as the Forester video. Learned a few lessons here. You know, when I started the winding on this side, I was doing like this looping thing back and forth instead of spiraling. The reason I did that was to try to minimize any risk of the wires poking through and being able to like touch a wire with your finger through this gap, which I also just addressed with the electrical tape, so I'm not too worried about that in the end. But when I started started all the wire around, it sped everything up a lot. Here I had to go back to the zigzag because you can't loop past the spoke here, but right here I spiraled it again, so that was fine. Yeah, so I guess that's about it. Thanks for watching, and let's see, one final temperature reading here, all the way up to 130 in some spot here. Nice. So this will feel pretty great on a sub-zero start later this winter. Yeah, see ya.